Hello everybody. Today we are going to discuss one of the most important topic in C programming, that is the concept of the pointer. So today in this first lecture video we will discuss the pointer basics. Then we will keep on unfolding the use of pointer in several cases, like for simple variables, for array variables, for structure, and how to pass variables in a function using the pointer. Okay, so we will go step by step, but first in this video lecture we will try to focus on basics of the pointer. So first of all, what is a pointer? So pointer is basically an address or location. So it is a variable just like other variable you studied. So it has type, storage, etc. How it is different from the others? I mean, how is it different from other variables? It is the variable which can store only the address rather than the value of a data item. So what I try to say, that when I declare one variable and that variable has a specific data type, in this case when I declare a pointer, definitely for a pointer there will be a variable name, but that variable will store only the address. Okay, so that is the basic difference. And from that point of view, the type of variable is same as the type of the pointer. So type of a pointer variable is pointer to the type of the data whose address it will store. For example, integer pointer, floating point pointer, and it can be the pointer to any user defined type, also like structure type, etc. They have a number of useful applications. Enables us to access a variable that is defined outside the function and can be used to pass information back and forth between a function and its reference point. More efficient in handling data tables, reduces the length and complexity of a program, sometimes also increases the execution speed. We will see all this through some examples. As you seen before, in memory, every stored data item occupies one or more contiguous memory cells. The number of memory cells required to store a data item depends on its type, whether it is integer, character, double, float, long double, etc. Now you know by this time that if it is a character type, then 1 byte is required. If it is integer type, then 4 bytes are required usually, although in some system you may find 2 bytes are required. If it is float, then 4 bytes are required, like that. Now similar to that, whenever we declare a variable, the system allocates memory location to hold the value of the variable. Since every byte in memory has a unique address, this location will also have its own address. To summarize, when I declare a variable, that variable must have a data type. That data type can be character, integer, floating, or double, or any other data type. Even it can be some user defined data type like structure. Now whenever there is a data type, then data type informs that two things basically. The data type informs two things. One is the amount of storage required, I mean amount of memory required to store that particular variable of that particular data type. Another, from that byte, how to interpret that data type. For example, character is of one data type, character data type is of 1 byte. Now 1 byte is required to character, and how it will be interpreted, that information is also known. If it is integer, then 4 bytes are required. If it is floating point number, then also 4 bytes are required. But the way those 4 bytes will be interpreted is different in integer and in floating point number. Okay. So whenever I declare one variable, then it must have some data type, and data type stores two information. One is how much storage or memory is required and how they will be interpreted, apart from the fact that where it will be located. Now regarding this pointer, it always stores the address of some memory location. So specifically it is used to store the address of some variable. Now you understand, if I say it is an address, then it will be a whole number. It will not be a floating point number, like fractional values is not required. That is one thing. Another, if I do not use some reference frame in order to define my address, then mostly the address will be unsigned. Okay. Now if it is unsigned, and if I assume it is unsigned int, then like int, 4 bytes are also required for storing the address. Now interesting fact, you try to understand that if it is the case that in order to store the address, pointer variable is there, so pointer variable will store the address of some memory location, and I know that address will be unsigned integer value, then the question is that whether there is a need of any other data type information or not. Yes, it is required, because it will store the memory location. But after reaching to that memory location, how to interpret that data in order to store that information, the pointer also have some data type. Okay. So although the pointer is storing irrespective of the variable, so basically pointer is storing the address of the variable, but irrespective of the data type of the variable, the amount of memory required is same. But the difference is that how it will be interpreted. That's why data type information is also required along with the pointer. But this is an advantageous situation where in order to store the address of a variable of data type character, or the address of a variable of data type integer, or the address of a variable of data type float, although their data types are different, but the data type with the same address, which means that the amount of memory or the amount of storage required for that particular variable is same. So we will see in later video lecture that how we can exploit that one to use one pointer variable for different purposes based upon our requirement. Now to elaborate with an example, consider the statement like int xyz equals to 50 semicolon. Now you know that here I am declaring and initializing variable xyz whose data type is integer and it will have value 50. By this, actually compiler instructs the system during the program execution, okay, that you reserve some memory location and copy 50 in that particular memory location. Okay. Now suppose the address location chosen is 1380. Please note that this address location definitely will vary if you print your address location in your system. Okay. So throughout our video lecture, we will assume that this address location is some unsigned integer value, and definitely it will vary with the address you will get in your system. Okay. But I believe that you can able to discriminate that one, and throughout, although we will use some value like 1380 as memory address, then you understand that this is an assumption and without any loss of generality to the topic. Okay. So after this slide, what we summarized is xyz is the name of the variable, 50 is the content or the value, and 1380 is the address of that variable. Okay. So what will happen that when you declare a variable like int xyz equals to 50, then during the compilation process, one memory location will be reserved and the address of that memory location I am assuming as 1380, and the content of the memory location will be 50. Okay. So during execution of the program, system always associates the name xyz in the address 1380. The value 50 can be accessed by using either the name xyz or the address 1380. How we will demonstrate that? Since memory addresses are simply numbers, they can be assigned to some variable which can be stored in memory. Such variables that hold memory addresses are called pointer. Since a pointer is a variable, its value is also stored in some memory location. Okay, that is an important observation. Suppose we assign the address xyz to a variable p. So as of now, my declaration was int xyz equals to 50, and I mentioned that compiler will allocate one memory location. I am assuming that address of that memory location is 1380 and the content is 50. Now since it's an integer variable, so 4 bytes will be reserved. Those 4 bytes will start from 1380. Okay, so I know only the starting address, and you will also understand that if I know only the starting address and if I know how many bytes are reserved for this particular variable, since I know the data type, then it's easy to retrieve that particular content and interpret that one, isn't it? So from that point of view, so xyz is given a memory location 1380 where the content is 50. Now when I am declaring one pointer variable, I mean a variable which is supposed to store the address of some variable. In this case, if I assume that it will be storing the variable p will be storing the address of xyz, then in order to store that one, p also needs some memory location, right? So p will have as a content the address of xyz variable. Okay, so in this table I am showing that one. So here variable is xyz, its value is 50, its address is 1380. Next, in order to store the address of 1380, that is the address of xyz, I am declaring another variable p, and it will store 1380, which is the address of xyz, and the address of p, since it is a memory location and storing 1380, so it must have some address. So address of 1380 is 2545. I am assuming that. Okay. Now this is the internal arrangement in the system, and I am not interested about this value of this address as of now. But how to assign this one means I declare one variable p, which is a variable to store the address of xyz. How I will declare, I will come shortly, but before that, in order to assign the address of xyz, what I need to do, or what I need to write in p, that is here p equals to ampersand xyz semicolon. So by this ampersand xyz, I am basically passing the address of xyz and that address is going and storing it P. Now perhaps you will able to realize that when I have a printf statement, then only xyz kind of writing or parameter passing in printf function is enough, but for scanf why I need to pass ampersand xyz. We will see that one in more detail later, and we will understand in more detail, but for the time being, so P equals to ampersand xyz indicates that xyz is a variable whose address is I am storing in P. Now looking inside the memory, so in memory each and every location have some address. Okay, similar to a situation that where they say hostel or hall is there, and there is a number, room number in each hall. So that way some storage is required. Now also you understand that when some storage is required, then in order to store some data inside that one, so you just do an assignment, and if you do some assignment, each cell also stores some value. Then you will see that some after some assignment, say the at location 14 23 is assigned, at some other location 42 is assigned, that way. So this is the content and this is the address. Okay, so at this point please do not be confused that since 23, I understand 23 is an integer value, and since it is an integer value, then it has an address, and if I assume 14 is the starting address, then 4 bytes, so why it is 15, it can be something else. I understand that one. So at this point I am just using semantic, not the actual values. Those actual values I will demonstrate when I will discuss in context of some program or programming example. I will come to that one. But in this semantic, so my intention is to demonstrate that what is address and what is content. And from that point of view, 14 is the address and 23 is the content. Now, if I define another variable which will store the address of this memory location, that is 14, then I will store this address to that 14. Okay. Now the interesting fact before I proceed to the next slide is that when I am storing say 23, I know it is integer, because say I declared that variable, and say I declared int xyz, and say xyz is an integer data type. Compiler allocates, okay, you are given position number 14 where you can store your value, and because of that one, based upon some assignment, 23 has come and stored in this memory location position number 14. Now if I have a separate memory location, in that memory location what I will do, I will store this address 14. Now look, from content point of view, 23 is very similar to 14, whereas 23 is an integer value, whereas 14 is an address. But looking at that data only or the content only, 23 is same as 14. So how do I know that 14 is basically an address? It's not a value. That I need to do by a special declaration of the variable which will store actually this 14, that is using pointer. Okay. Now after doing that one, then I will know that 14 is my address, it is not the content. Okay. So the content is in the location of 14, not 14. Okay. So next, don't confuse the address referring to a memory location with the value stored in that location, although they may be of same type, because address is always, as I mentioned, unsigned int, whereas the content may be int, may be unsigned int, may be other also. But specifically when the content is unsigned int or int but current value is a positive number, then do not be confused with that one. So further elaboration, so that you are not confused with the content and the location. Variables name memory locations which hold the value. Okay, so here the situation is x is the name of the variable whose address is 1024 and 32 is the content. Usually during the compilation process, the compiler generates one symbol table where it has the mapping of this variable name and some memory location. But this 32 is assigned during the program execution, then the content also will be updated with that one. Okay, but if it is say assigned, then it can be assigned before also. A pointer is just a C variable whose value can contain the address of another variable. It needs to be declared before use just like any other variable, because it is also a variable whose data type is data type star. So general format is data type star pointer name. This pointer name you can consider as the name of the variable. This data type is either some basic data type like character, integer, float, double, long integer, etc. But this star, you note this star indicates this variable is a special kind of variable which will store only the address of any variable and its name is pointer. Okay. So three things are specified in the above declaration. The asterisk tells that the variable pointer name is a pointer variable, which means it is a variable whose data type is defined here as the data type, but it will store only the address. Pointer name needs a memory location similar to any other data type variable declaration. Pointer name points to a variable of type data type. That is important. You see, as I mentioned, that if you assume, and it is fact, that pointer name is a variable which will store the address of a variable. Now that address, irrespective of that particular address, is dedicated or reserved for which variable and what is their data type, irrespective of the address is always unsigned int. If the address is always unsigned int, then I can use the same number of bytes which is required to store an unsigned int, irrespective of the fact that it is used to store the address of a variable, what is their data type, isn't it? If I assume 4 bytes are required to store an unsigned int, then always a pointer variable will, or in this case pointer name, will require 4 bytes to store the address of any memory location. Sorry, the address of any variable in the memory location. Okay. Now, if it is the address of any variable, and I know that 4 bytes are required to store the unsigned int, then 4 bytes will always be allotted. Then where there is a need of this data type, here comes the application is, okay, you are storing one address in one particular memory location and you are telling that as a pointer, because that address is the address of some variable. Now what you will do by that? In application, the application of this is that, or of storing this variable is that, you will go to that memory location and do or perform some execution on that one, right? If that is the situation, then after looking at this address, then jumping to this address location, you have to infer the content of that data, or you have to infer the content of that address location. Now when I say you have to infer the content of that data location, now you see that address is always the starting position, starting address, but how many bytes from that starting position and how that will be interpreted as a character or as an integer or as a float, and how many bytes are to be interpreted. So those information is not incorporated either in this pointer name variable or in that particular memory location. It is incorporated in the data type. So if you declare the data type, then it understand, okay, so this pointer name or the name of a pointer variable at this position will store the address of a variable whose data type is this data type. Now you see, now it is easy. So this variable name or pointer name will store the address of a location. You go there, after reaching there, then this data type information will guide you that how many bytes you have to pick and how to interpret, because this data type have that information. That way, although you require the same amount of bytes in order to store the address, but basically you need to declare the data type also. But here is one interesting observation, since it is same for all the variables irrespective of their data type, so there is a possibility that I can change it, because when I will change it, then no extra memory is required for the storing of the address and no less memory is also required. So those errors which has occurred due to promotion of a data type or demotion or truncation error, etc., those will not appear. And how smoothly we can do, we will see later. So the first example is here now: int star count, float star speed, character star c. Again, count is the pointer variable which will store the address of some integer variable. Speed is a pointer variable which will store the address of some floating point variable. C is a pointer variable which will store the address of some character variable. Okay, star indicates that one. So this count, speed and C, all of them will have, or all of them will store an unsigned int each. Now once a pointer variable has been declared, it can be made to point to a variable using an assignment statement like ampersand xyz. So this is called as the pointer initialization. Okay. Now how can I access the address of a variable? Just now I have shown that one, and also you are using this one since you started to write your hello small program in using scanf. The address of a variable is given by the ampersand operator. The operator ampersand immediately preceding a variable returns the address of the variable. Now example is here, p equals to ampersand xyz. The address of xyz 1380 from our previous slide is assigned to p. Similar to that, the ampersand operator can be used only with a simple variable of any type, including user defined types or any array element like ampersand discuss, ampersand x0, this is the array, and ampersand x I-2, this is also an array item or array element. I-2 is indicating that inside the array subscript you can have arithmetic expression also, and I know that by this time you are familiar with this. However, there are some illegal use of ampersand which is not allowed. So first one, ampersand 235 pointing at constant. What does that mean? That doesn't mean anything, because no memory, explicit memory is required to store 235. 235, in order to store that one, some memory is required, but that is not having any particular address. So this is a constant, and since it's a constant, so I can store it in some area where the changes are not required. So this is a constant. Now int array 20 and ampersand array, so pointing at array name. Okay, so sometimes you may find, based upon the support of your compiler, what kind of compiler you are using and what advanced features are there, you may not get any error. Okay, but this is also not correct usage. So correct usage is 0, ARR 0. Now ampersand a plus b pointing at expression. So for this you clearly understand that what does this mean, a plus b. This means so a is a memory location, b is a memory location, but when I am writing some expression, then what is the address location of expression? That doesn't mean anything, right? Whereas our pointer is only for the expression. In all these cases there is no storage, so no address either. Okay, so for this ampersand AR specifically, no storage means that array ARR without ampersand, that will give you the base address. Okay, again I am telling, sometimes you may or may not get an error, but these are not a legal use. You should use properly. Here is a full scale example of dealing with the pointer variable. So has include stdio.h, int main, int a, float bc, double d, char ch, and I am assigning some values to the variables based upon whether it is integer, floating point, double or character. Similar to that, variables are allocated. Next, what I am doing, in each line corresponding to one variable, I am having its content, that is %d, is stored in location, the address in %u. As I mentioned, the address is unsigned int if I am not using any referencing. Sometimes it may happen that I am using some references. So this position is my 0th position, so if I go up then it is increasing, if I go down then it is decreasing. So if that situation will not happen, then it is always unsigned int. Okay. Now if it is unsigned int, then it will be printed as an unsigned int using %u. But if you write %x, then the address will be printed in hexadecimal. Now you know hexadecimal means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then instead of 10, 12, 11, 12, 13, 14, 15, it is A, B, C, D, E, F up to F. So 16 different digits. Now this A, B, C, D, E, F, they can be in small or capital. Here those doesn't make any changes or differences. Okay. And after this 5 printf statement, I have a return 0. Now if I execute that one in my system, this is the output. Please note that these initial values will be same, but this memory location will change for you. Okay, it may not be same, so do not be panicked with that one. So you please try to understand that whenever the program is executing, then based upon the availability of the memory location, the program is assigned. This is similar to the situation you can consider that, say you are admitted to IIT Kharagpur. Now in the first semester, if you are in this campus, then based upon the availability of the hall, you will be allotted. Now if for some reason, okay, so like this COVID pandemic, you are not in this campus, and except say first year, if I assume that other students are admitted, then they will be allotted and you will come later. If you come later, then based upon the availability of the halls, in the rest of the halls you will be allotted. Although in this case situation is little different, because I have a knowledge that first year will come but they will come later, but for the system who is executing your program, to the system that knowledge is not there, whether you as a user or programmer will come and then execute this program. So whenever you will execute, whatever is available from there, it will allocate to you. And this allocation is the address which will store these variables. Now you see, as I mentioned, that irrespective of what is the data type of the variable, since it always stores the address of the variable, so it will be same. And you see that value varies, definitely it will, that you understand, but their data type, their content looks very similar, and the change is in this last digit, and based upon that one, few changes are there. Okay. Now how to access a variable through its pointer? So if I write, say, only p, where p is a pointer, I declared p as int star p, and I assigned p equals to ampersand xyz, where xyz is an integer variable and is declared as int xyz. Then in order to access that p, if I write just p, if I go back again, then you see that here I am writing ampersand a, and its value is 322.122.4908. So this value is the address of a. So address of the memory location where the integer variable a is stored. Now if I declare one variable, I mean one pointer variable, say star p, and I assign p equals to ampersand a, then if I print p, then it will print 322.122.4908. But if I am interested to access 10, which means the content of a through that pointer, then I have to give the star, and this star is indirection operator. It informs that, okay, I am asking you to print star p, means I am asking you to print the content, but it is not your content. You look at your content, and this is the memory address. You go to that memory address, and in that memory address, whatever is the content as per the data type I mentioned to you, you print that one. This is about the printing, but for other reading, writing, etc. also the meaning will be same, but this is an indirection. And since it means like you should not use your own content, rather in the content I am giving you the address of one location, you go there and pick that one. So as if like I am storing to you or I am depositing to you one key, and when I ask give me the stuff, then I am not asking the key, but I am telling you, okay, use that key, open that box and give me the content. So there is one indirection, directly I am not accessing. Okay, so here is the situation: int a comma b, int star p, p equals to ampersand a, p equals to star p. So I am declaring two variables a and b, and then I am declaring one pointer variable p. Now by this time, you know, if I wish to declare one pointer variable, then I have to give star. So that is the basic difference between this a, b and p. So this indicates the compiler that a and b are two integer variables, whereas the star p, here p is a pointer variable. So p will be assigned p equals to ampersand a. Now when I say star p indicates it is not the content of p. If I say just p, then it will print ampersand a. But if I say star p, then it will look what is my content, and that content just now I assigned as the address of a. So you go to this address, that is at the location where a content of a is stored, and you assign that one to b. And that's why star p indicates a, and since star p indicates a, so this will evaluate to b equals to a. So these two are equivalent. Okay. So here is another example. You see that inside the main function a and b, two variables, c is a third integer variable, and I am assigning that one with 5. Now integer star p, a equals to 4 multiplied with c plus 5. This is a simple arithmetic expression. Okay, so the value of c will be added with 5, more 5, so c plus 5, so 5 plus 5, 10, multiplied with 4, that is 40, that will be the content of a. Now what I am doing, p equals to ampersand c. So the address of the c is now stored in p, where p is a pointer variable and its data type is integer, which means p will store the address of a variable whose data type is integer. That way, inside p I can store the address of a or b or c. All three can be stored in p, but not at the same time. At a time, only one. Okay. Now p equals to ampersand c. If I write that one, then in order to access the content of c, I can write star p. Just in the previous slide, I demonstrated that one. So when I say b equals to 4 multiplied with star p plus 5, then this star p is nothing but this c. So they are equivalent, this c and star p. Okay, so when I will print a and b, then I will have the same value, a and b both are 40. Okay, now you see, as of now we are trying to understand the basics of the pointer, and at this point you may think that if I can write c plus 5 and there is a direct access of c, then why there is a need of an indirection like star p, where I have to look at the address, then I have to go to that address location and I have to pick. Won't that be time consuming compared to this c? In this context, you may think about that one, but when you will see a lot of other applications of this one, then you will understand that why there is a need of pointer in C. Okay. Now here is another example, again for the demonstration purpose. So two variables x and y are of data type integer. Only one pointer variable ptr, and since it's pointer, so it is star, or I need to declare one pointer variable, that's why I am writing int star ptr. So ptr is a pointer variable which will store the address of x and y whose data type is integer in this context. But in general, ptr is a variable which will store the address of any integer variable. Now x equals to 10, I am assigning pointer is now ampersand x, which means the address of x is in ptr now. Now if I write y equals to star ptr, in the previous slide I did that one using a, b and c, right? So what will happen? You understand that the content of ptr is an address. In that address location, the content of x is there, so that is 10. So when I write star ptr, one indirection, and because of that one, 10 will be assigned to y. Okay. Now if I print like previous time, so its value and where it is stored using unsigned int, then, and also if I assume that address of x is supplied as this one, address of y is supplied as this one, and address of pointer is supplied as this one, then what will be the output? So here is in my system, but it will definitely vary in your system. So the value of x is 10 and it is stored in this. So this is, I am assuming, and I am assuming means that I am storing that one in this particular location. Then star ampersand x. Now you try to understand this ampersand x here indicates a point address of x. Okay, and star to that indicates one indirection which says in that address location there is a content, you print that one. So star and ampersand in combined will give you the content of x. So that's why I am getting 10 also. Next, star PTR. So star PTR is the content of x. So this PTR is ampersand x. So that's why I will get again x here, and this pointer PTR is nothing but the address. So in the first 3 lines the content will be same, but it is written in 3 different ways and its access is also different. Okay. In the 4th line I am starting with the variable y. So y ampersand star PTR. So when I say star PTR, then star PTR indicates the variable, the address of which variable? So this star is x. Now ampersand x, that will be printed. So ampersand x means what? So this is the address of x. So it will be printed in the 4th line, but the content y is 10. So this 4th 10 is not from x, rather it is from y. And because of the fact that y equals to star PTR, so the content of x through the indirection of PTR is now copied in y, and that's why I am getting 10 here. Okay. Next, in the 5th line, PTR ampersand PTR. So PTR, you know, it will print the address of the content of the PTR, and content of the PTR is y, what? It is the address of the x. So which was printing here will now be printed here, and ampersand PTR means what? The address of PTR. Now from this text you see the address of PTR is 322.122.4900, so it will be printing here. And the 6th printf statement is y comma ampersand y. So ampersand y from here is 322.122.4904, that will be printing, and content of y is what? Equals to star PTR, which means in the PTR there is an address of what? Ampersand x. Go to that location where in x, and what is the content? 10. So you print that one. So it will be printed, and after that one it will be assigned to y. Okay. By printed I wish to mention that it will be accessed, basically it will be accessed or it will be read, and then it will be assigned to y. That y will be printed here. Okay. Next, what I did here, star PTR equals to 25. In order to validate that indeed star PTR indicates the content of x, so what I did, star PTR equals to 25, and after that I am printing the content of x. Now you see, now x equals to 25. Why? The star PTR is equals to 25. It indicates that star PTR means the content of x. So the content of x is now 25. So when I will print now x equals to this x, then it will print x. Okay. So further elaboration, so that you understand the basic of pointer, so that we can study more on this pointer. So int x, int star xp, so this is pointer to integer data type. Now xp equals to ampersand x, because it will store the address of x. Okay. Now this xp 1024 is the address of this x where 32 is stored. Okay. So star xp equals to 0. When I say, then where will be the change? Star xp means that star xp, so here the change will be here. Similarly, star xp equals to star xp plus 1 is nothing but adding 1 with the content of x. This is better explained as add 1 at the content of x, rather than it will be 1, because just now I initialized with xp equals to 0, that's why it will be 0 plus 1, so 1. But if this statement is not there, then this statement will say that add 1 with the content of x. Okay. Now value of the pointer, declaring a pointer just allocates space to hold the pointer, it does not allocate something to be pointed to. Local variables in C are not initialized, they may contain anything. Anything means some garbage value, because you know that nothing is erased, so it is just superposed in the system. Okay. After declaring a pointer int star ptr, ptr does not actually point to anything yet. We can either make it to point to something that already exists, or allocate room in memory for something new that it will point to. Dynamic allocation, it will be done sometime later. In pictorial view, what I discussed so far is like, this is a memory bank. So this is the 0th position and the memory address increases this way. Let us assume this is 1500 position and this is 2300 position. We will be focusing in these two regions only. Let us declare two variables, int star p comma v. Now in both the cases, it will require 4 bytes, because 4 bytes are required to store that integer v, and 4 bytes are required to store an unsigned integer, the pointer here. Okay. So again, it is not the case that it is integer pointer, star p is integer pointer, that's why 4 bytes are required. 4 bytes are required to store the any memory address. Okay. Since it is required to store any memory address, since it is required to store any memory address of a variable, of course in the context of a variable, so irrespective of whether it is integer, character, float, etc., star p will require only 4 bytes. Now this v is an integer. Now let us assume that v is allocated in this memory location 1500 and star p in 2300. Again, this assignment is system specific, and I cannot guarantee that since this is occurring first, so it will come here, and since it is occurring next, then it will go there. But it will be assigned to something, and for the time being we are not bothered about that one. We are assuming just v is assigned here, p is assigned here. Now we are not initializing these two with any value, and also this is not declared, this v is not declared as any static variable, so no initialization. So what will be the value? So before the allocation of this memory to v and p, there was some value. Value means some zeros and ones. If I try to interpret that zeros and ones in some for v as a integer or for star p as an unsigned integer, then I will have some value. It may be 0, it may be non-zero, but I will have some value, but that value doesn't have any meaning. Okay. So I am doing the assignment. Now when I do p equals to %v, then what will happen? The address of v will come here. Again, the content is not set yet, but because of this assignment statement, the address of v, which is 1500, will come to this position. Clear? So you see that stepwise how it is going. Next, I am assigning v equals to 17. Now the content of v is 17. Okay. So when I was in this position, then only the memory location was allocated and no value was initialized by this program. So the value at that location, if I try to interpret, will be interpreted wrongly, because it will be interpreted based upon the previous ones and zeros which was stored in that location. But when I assign p equals to %v, then 1500 is assigned as the content of p. And when I say v equals to 17, then 17 is assigned as the content of v. Now it is initialized. Now I can do my operation. So if I write star p equals to star p plus 4, then what will happen? That inside this star p, here it is star p plus 4, the content will change. First star p will be it was previously 17 because v is basically 17. 17 plus 4, so it will be 21 initially. That transient state is not shown here. Then v equals to star p plus 4. So v equals to star p, p star, again it will go here. Basically by star p I used to mean v itself. So v plus 4. So by this star p equals to p, go for an indirection from 1500, come here, and this is your location where 17 is there. You add 4 with that 17, then you will get 21. The intermediate result is not shown here. Then it will be 21, and after that one, when you will execute v equals to star p plus 4, then with 21, because star p is again the content of v in this particular location, so with this 21, 4 will be added, it will be 25. Now the content is 25. So the content is 25 because of the consecutive execution of these two statements. Star p equals to star p plus 4 and v equals to star p plus 4. Sorry, here there will be a semicolon as per the C syntax. Okay. More examples of pointer in expressions. So if p1 and p2 are two integer pointers, so they will be declared as in star p1 comma star p2. The following statements are valid. What is that? Sum equals to star p1 plus star p2. You agree that that is what we have discussed. So there is an indirection. You go to that location and you do that one. So first of all, this is a piece of code. Before this one, definitely I declared sum, product, this product actually. Then p1, p2, all those variables are declared. p1, p2 both are assigned or initialized with some address, the address of some integer variable. Then only I am doing this one. But here the addition of two the addition of p1 and p2 in star form is allowed, and that will give you the content, and content will be added. Multiplication is also allowed. So in this case, so you see that two stars are consecutive. Okay. Now in order to avoid this, so avoid this means, so this statement is correct. Okay. First of all, let me tell you, this statement is correct. But if you are confused by these two consecutive star, because star is a binary operator and on the both the side of star there are two operands are required. So if you are confused, then you can put them in one parenthesis to indicate that star p1 is one pointer content and this is another one. This is allowed. This star p1 equals to star p1 plus 2 is allowed. Star p1 divided by star p2 is allowed, and this 2, so this p1 can appear on the left hand side also, this here. Okay, so it can appear in the left hand side also. So that also we demonstrated in the earlier examples also. And why I can write these two star is because of the fact that this unary star operator has higher precedence than the arithmetic, logical or biological operation. Arithmetic, logical or relational operators. Okay, so that's why basically I can have this one, but this is with the same meaning as this one, the second and third line. Now things to remember: pointer variables must always point to a data item of the same type. Same type is important. So float x and int star p, and then writing p equals to ampersand x will result in wrong output. Why it is wrong? That I discussed elaborately. Look, although the pointer variable will reserve 4 bytes and will store an address which is on-site integer, but going to that address location, how to interpret that data is not clear to it until I attach some data type with it. Now by this declaration, I am declaring P with a hope that it will have the address of a memory location where the content will be interpreted as an integer, but when I am writing P equals to ampersand x, then it is actually having a floating point number. Now the interpretation of an integer and floating point number is completely different, so that's why it is a wrong, it will give you wrong output. Again, sometimes you may get some error, sometimes you may not get some error. That doesn't mean that you are doing it correctly. Okay. So when there is no compilation error, which means from compiler's point of view, so either there is no problem or compiler do not able to understand your logic. But if it is a mistake, then it can be in the logical step also. So it is entirely your responsibility to look after that. Never assign an absolute address to a pointer variable. Okay, so int star count, after that one, do not write count equals to 1268. Okay, so that is also not allowed. So that's it for the basics of the pointer. Okay, so what we have discussed so far, if I wish to summarize, then I mentioned that we are incorporating one concept of pointer, which is nothing but a variable to store the address of any other variable. That any other variable can be of any basic data type like character, integer, floating point, long, double, long int, etc., or can be of any user defined data type like structure, or it can be array, etc. But ultimately I am declaring one variable which will store the address of a variable. Now since it will store the address of a variable irrespective of the data type of the variable, so the memory required to store that address is same for all the different variables with different data types. Still, I need to inform the compiler and I need to write that one during the declaration of the variable which will store the address, and we are calling that as a pointer, that what will be the data type of the variable whose address it will store. That information is very much important because when I will reach to that address, then I need to infer that one. Okay, how to infer that one? For that I need to store that one. I mean the data type I need to store. Okay, and I also discussed few legal and illegal uses of the pointer. Now in the next video lecture we will discuss the use of pointer for array, how I can pass it to the function, and I also demonstrate that at this case, in this situation, when you are thinking when I can directly access one variable, then why there is a need of one more indirection in terms or in the name of a pointer, where first I need to go to that content of that pointer, then get the address, then go to that memory location, then get the content. So instead of that one, if I go for a direct access, then it is easy. As of now it is true, but during the function call and passing variable and passing the argument in the function or accessing the array element, and in several other cases I will demonstrate that it will be indeed useful for those kind of cases. Okay, so thank you.